Hello and welcome to this 3DO webinar preview. This is a small sample of the original presentation, but if you'd like to view the full webinar, please click the link in the description below.
Welcome everyone. Thank you for attending this seminar. We're going to cover a lot of things today. The presentation is going to start out by talking about why quality systems exist and what benefit they are for the users or for the people that are using them. We are also going to talk about traditional manufacturing quality management and also about 3D printing. Is it really different than what traditional process controls, process capabilities are? We're going to talk also about the 3DO approach to quality, and then we're going to end up with how to develop your own quality plan. And after we finish, there'll be question and answer time period, and you can ask any questions you like. Oops, sorry, went the wrong way. Okay, we're going to start off with definitions just to make sure everybody understands what we're talking about. When I talk about 3D printing or AM or additive manufacturing, I'm talking about the same thing. It's about digitally manufactured parts in an additive fashion. So those three terms are pretty much the same. I'm going to use them as if they're the same in this presentation. Process control is really understanding predictability of output. When you have a controlled operation or a controlled process that you're dealing with, that process has predictability of output, or you know what's going to come out of that operation. Capability is different than control. Control just tells you what your distribution looks like in terms of what your output is at whatever process you're dealing with and whatever critical variables you're monitoring. Capable processes are processes where all of the distribution coming out of that process is within the spec limits of the part. So 3 sigma is usually the CPK of 1, or saying that the processes are capable. So if you have a capable process, 99.73% or more of your parts fall within the spec limits of the part. Metal 3D printing is comprised of many different technologies. I'm sure most of you are aware that there's plenty of different technologies to deal with. There's our process at 3DO. There's all the laser sintering processes that are there, binder jetting, and all the other products that are generated from additive manufacturing in metals. So when I talk about these different technologies, I'm just talking about a grouping, and we'll talk about each one. When I talk about prototyping, I'm talking about 10 parts or less. In production, we're talking about ongoing serial production. So production is really the volume, and that's what we're going to focus on today. Parts that are coming out in larger volumes greater than the 10 parts for prototypes. And for 3DO, we're going to talk about 100 to 10,000 a month, which Matt covered earlier. Okay, my first thing is, why do quality systems exist? They exist to provide products that are consistently met customer requirements. So basically, if you have a prototype, you can measure all the dimensions on the prototype, and you can rework it if necessary and do post-operations or to make it work. To be competitive and to have a quality volume manufacturing, that's not the best way to go. As a matter of fact, it's usually impossible from a capability and a cost standpoint. Also, if you're 100% inspecting the parts, there's no chance that you're not going to get escapes. Statistics say that escapes will occur. So the real reason for doing quality systems is to assure that you make quality parts and build that quality into the process and don't inspect it in at the end. Also, quality systems help us understand our process capability and ensure repeatability of parts. So the systems that you put in are really meant to give you feedback on how your process is flowing and if everything is working as predictable and if those distributions are within the spec. I put a DMAC emblem over here. It's a little insignia. We do use DMAC here and Plan, Do, Check, Act. things of that nature to do structured problem analysis for our improvement activity. Okay, now we're going to talk about traditional manufacturing and their quality management and how that works. To start off with, traditional manufacturing has effective process controls. So they couldn't not have effective process controls and still be volume manufacturers. CNC machining industry has over 30 years of experience in process control systems and development. So they've been able to take all their variation that they have and develop control systems around it to get predictable performance output. Now, it wasn't like they started out and they didn't have any problems or variation that occurred in their process. They had tool wear, they had how they set up the machines, they had all the different machines that they were trying to run. And what they've done is taken the known systems for doing quality control, and they've optimized them for their processing in order to give them process controls to tell them what to do and how their performance is going to be. So when they look at their process, they look at the tools, they see the way the tools are wearing, they develop degradation curves, and they know to check the parts to monitor that and then when to change the tools. There's a lot of other variation that occurs. I've listed them on the side. Some of it is lot-to-lot variation, operator dependencies, feeds and speeds, etc. But they've been able to work around it. My point is, they've had 30 years of experience. They figured out how to do it. It works well today. There's a good number of shops out there that are totally capable of meeting requirements in today's environment. The next one is metal injection molding. They've also had about 30 years of experience. They had significantly different variables that they had to deal with. The good news is that they were able to build quality plans around what their variability is and came up with process controls that allowed them to control their variation and get predictability of parts. They also had to work with a lot of variables, the sintering process, molding variation, post-processing variation, tool wear and degradation, lot-to-lot, a lot of different things. In addition, the material variability and humidity variation. So again, they took a traditional process. It took quite a while. They developed process controls around it, and they were able to get predictability of performance based on those control mechanisms. Okay, I'm going to go through a couple of things in the quality toolkit. The first one is control chart. Some people refer to it as a performance chart, but basically what this is it's looking at the process over time to tell you what variation you're seeing in the process. Now, this particular chart actually is real data from us on the height of one of our parts. And what we're seeing here is the distribution around the mean that these parts do over time. And what we're looking for is to make sure it stays within those control limits and doesn't have any runs or trends that would show unpredictability of performance. The real value here is that if we start to see things going out, we can go in and make adjustments and fix it before it goes out of the specification limits as we're building the parts. So this process also happens to be in control, and it's in control because all the parts are within the control limits and they don't have any runs or trends within the sample. The other tool that I like to use is a histogram. The histogram shows the same data, and it's the same data that we had on the other chart. It just shows it as a single lot and shows the distribution of the data. The red lines there are the spec limits, and the little blue line chart there is really showing the curve of the distribution. And as you can see, the process is capable. So we should see all the parts predictable and performance coming out of that process within the spec limits unless we start to see changes in that control chart. So these are two of the charts that I use in the startup of an organization that allow me to understand process capability and assess control within each process that I set up.
Thank you for watching this webinar preview from 3DO. To view the full webinar, please click the link in the description below. If you'd like to learn more about 3DO, please visit our website at www.3deo.co.